importance of dual. So what is the importance of dual? Suppose one linear programming problem is given, then uh, we use dual, write is dual. So what are its importance? What are the importance? So importance is what? First you see, if the primal contains a large number of constraints and a smaller number of variables, then the labor of computation can be considerably reduced by converting it into the dual problem and then solving it. Means what? Actually, when we primal problem is given, and when we convert it into the dual, then you will see. Suppose your example I have given, you see, if number of constraint is 5, so number of inequalities, constraint means all the equality or inequality. If number of constraint is 5 and number of variable is 2, okay, then in solving primal by simplex method, the basis matrix will be 5 by 5 matrix. Okay, and it will require much time in computing each simplex table. But if we convert the problem into dual, then we get only the 2 constraints instead of 5. It can be solved easily. So here you see, suppose one problem is given, primal problem is given, and here 5 constants and 2 variables. So when we make the table in simplex method, then you will get 5 by 5 matrix. Okay, but if we convert it into the dual, then you will see there will be 2 constraints. Okay, so 2 constraint means what? Then we get 2 by 2 matrix. Okay, I here 2 by 2 matrix. So then our labor of computation will be less. So this is one of the importance of dual. And next one is what? The interpretation of the dual variable from the cost and economic point of view proves extremely useful in making future decision in the activities being programmed. So actually this one will be what? If we use a dual problem, then one important one is our labor of computation will be less, and another one is here in point of cost and economic point of view proves extremely useful in making future decision in the activities being programmed. So this is, we can actually, linear programming problem is what? In linear programming problem, we make the decision, means what cost, means if we manufacturing suppose one belt problem or a toys problem, then we can first formulate the problem and then we can, yes, how much, suppose if we sell rupees, suppose costing price we can easily calculate. Suppose our total costing price is 50, then our selling price is suppose 100, then this gives us the profit. So this is one of the importance of the dual. And next table is what? To read the solution to the dual from the final simplex table of the primal and vice versa. So I am audible, ne? Arbaj?
Yes, sir, you are.
Okay. So here next one is what? Till now we convert from primal problem to just dual. Next one is what? After converting the primal problem to dual, then you solve this problem. Okay, so then after solution, how to read the solution? So this is the procedure. Okay, so actually when we convert one primal problem to dual problem, then this gives us the solution of the dual. So original problem is primal. After conversion, this gives us the dual. And when we solve it, then this gives us the solution of the dual. But we need the solution of the primal. Then what is the procedure? So this is the procedure how to here read the solution to the dual from final simplex table of the primal and vice versa. First, you see, it is important to note that final simplex table of the primal problem contains the optimal solution of the dual and vice versa. For this, we observe the following rules. So what are the rules? First, you see, value of the primal objective function is equal to the optimal value of the dual objective function. Means max ZP equal to, we write mean ZT. And next, number 2 point will be what? Delta J. Delta J is same as earlier, Cj minus Zj. So with sign, changed this is the important line, slack or surplus variable in the final simplex table. For the primal are the values of the corresponding optimal dual variables in the final simplex table for the table. So I have given one example, then this will be easy for us. What is the number 1 and number 2, what it says. So next you see the question first. Using the dual, solve the following linear programming problem. Okay, so max z equal to 3x1 minus twice x2 such that x1 less than or equal to 4, x2 less than or equal to 6, x1 plus x2 less than or equal to 5 minus x2 less than or equal to minus 1, x1 comma x2 greater than or equal to 0. Okay, so here mention using the dual solve the problem. So first we convert it into the dual. Okay, next we solve, then solution gives us the dual, but we need the solution of the original problem. Next again, how to write is solution of the primal. Okay, so here given objective function is what? Our given objective function is maximization or minimization?
Maximization.
Max.
Maximization. Okay, and here constant, how many constants here? How many constants
4.
in the primal? Oh, yes, 4 primal. So next, here when we convert it, and how many variable?
2.
2 variable. So you see here, in the original problem, in the primal problem, 4 constraint, 2 variable. So when we convert it into the dual, okay, then in dual we get 2 constraint and 4 variable. So this is one first importance of the primal. First one is says like this. If you solve this one, here 4 constraint, 2 variable. When we convert it into the dual, then we get what? Then we get 2 constraint, 4 variable, right? So here I have written directly its dual. So, or you can solve as earlier problem. First you find out the dual, how to convert. Okay, so you write this coefficient matrix or etc. Solving this, you will get the dual. So our problem is maximization problem. So first you check whether our problem is standard primal form or not. Maximization, all constant sign should be less than or equal to. So here you see all constants are less than or equal to. So this is our standard primal form. So we can easily convert it into the dual. So maximization, so its dual will be minimization. So I have written directly the dual of the given problem is by mean z dt for dual. Next, you interchange the role of the coefficient of the objective function and constant term of the constraint. So you see in dual, dual, we write what is the constant term of the constant in the primal? 4, 6, 5, minus 1. So we can write 4 W1, 6 W2, then 5 W3 minus W4. Clear? Such that next you this one coefficient of means coefficient you write the transpose of the coefficient of the matrix. Okay, so here you see x1 first constant x1 is 1, second constant x1 is 0, third constant x1 is 1, fourth constant x1 is 0. So this one will be w1 plus 0 into W2, then 1 into W3, then 0 into W4, and reverting the inequality, so greater than or equal to 3. Similarly,
Sir, like
in
why like
primal,
greater than equals to 3? Like where did
eh,
that 3 come from?
greater than or equal to 3 means you see objective function, primal objective function coefficient is what? Primal objective function coefficient 3n minus 2. 3n minus 2. So this is greater than or equal to first one is 3. Change, na?
Oh, okay,
So
sir.
this
Yes,
is
sir.
greater,
Yes, sir. I understood.
clear?
Yes, sir.
And next one is 0 into W1 means x2 coefficient of the first in the primal x2 coefficient is 0. So 0 into W1 in the second constant coefficient of x2 is 1, so plus w into 1 into w2. Third constant is 1, so 1 into w3, then minus 1 into w4. And greater than or equal to minus 2 means you see the objective function coefficient of the primal minus 2. So first one is greater than or equal to 3, and second one is greater than or equal to minus 2. So clear up to everyone? So you see, or you can first, same as earlier process, first you write is dual, you will get this one. I have written here shortcutly, I have written. You can write here, we need half piece, okay, or 6-7 lines we require for converting primal to dual, then you will get up to this step. You will try, when you solve, you will try, you will get the same result. So up to this we get. So this is our dual problem, mean ZD. Okay, so next we solve it by simplex method. So in simplex method, what is the rule? Always objective function we make it into the maximization, and all constant terms should be positive. So our here, when we convert it into the dual, this is minimization, mean ZD. So first we write is max ZD. So this is max ZD dash. And when we write this is max ZD dash equal to minus mean ZD. Then you write value of mean ZD is minus 4W1 minus 6W2 minus 5W3 plus W4. And next what we do? Next one is first constant, okay. Constant part is 3, no problem. Second constant term is minus 2. Constant part is minus 2. So you make it positive by multiplying minus 1. So this is W1 minus W2 and 3. Then minus 1 is plus W4 less than or equal to 2. Okay, so here you see we get one is greater than or equal to symbol, next one is less than or equal to symbol. Okay, so next we make it into the equality. So in the first constraint, here you see first constraint we use here surplus variable, and the second constraint we use here slack variable. So here you see introducing the surplus variable W5 in the first constraint and slack variable W6 in the second constraint. So here you see when we use here surplus variable, then immediately we use another variable, artificial variable. So artificial variable when we use depending upon for getting the identity matrix. Okay, but in this problem you will see we will not use here artificial variable. So why we will not use here artificial variable here mentioned. So next page you see W6 in the second constraint. The constraints of the dual problem reduce the following equation. So you see in the second equation will be, in the first constant will be this one, W1 0 into W2 plus 1 into W3 plus 0 into W4 minus 1 into W5 equal to 3. And second constraint will be 0 into W1 minus W2 minus 1 into W3 plus 1 into W4 plus W6 equal to 2. And next question arrives, why we will not use here in the first constraint artificial variable. So here we will not use the artificial variable. Why? Because without using artificial variable in the first constraint, we already got the identity matrix. From where you see, first one is W1, first equation W1, coefficient is 1, and second equation 0 into W1. So 1 0 already got. And last one is, you see in the second equation, last one when we use W6, so first equation 0 into W6, so 0 1. So 1 0 and 0 1 we already got. So for this reason, without using artificial variable, we can solve this problem because already got the identity matrix. So here you see, since identity matrix I2 is present in the coefficient matrix, so there is no need to introduce artificial variable in the first constraint. So next, here you see identity matrix we get from which variable? W1 and W6. Okay, so here total 6 variable, 2 equation. So 4 variable is equal to 0. So which 4 variable is equal to 0? W2, W3, W4, W5. Because W1 and W6 gives us the identity matrix. So these 2 variable we cannot consider equal to 0 because this gives us the basic variable. So taking W2, W3, W4, W5 equal to 0, then we get W1 equal to 3 and W6 equal to 2. So this line is clear or not? Up to this? Up to this clear or not?
Yes, sir.
Yes, sir.
Okay, so here you see everyone sometime in your mind may ask question, why you will not use here artificial variable? Because someone, if you use artificial variable, then you see here we get another extra column. So our computation will be more, calculation part will be more. Okay, here suppose W1, W2, W3, W4, W5, W6 up to 6. But if you here artificial variable, then up to W7. Okay, but here no need because one important question is what? Why we use artificial variable? For getting the identity matrix, but here already exists. Identity matrix already exists in W1. First column of the identity matrix exists in W1. So we will not use here artificial variable. Okay. Then
Sir,
same process. Yes.
can we also take W1 equals to 0? Like, is that like possible? If we like want?
W1 equal Argos.
Yes, sir. Like W1 equals to zero. Like my question was like how do we know that which like variable that needs to be equals to zero?
Oh, yes. So you see, this is from here. First equation is W1 0 W2 plus W3 0 W4 minus W5 equal to 3. Second equation is 0 W1 minus W2 minus WT W4 plus W6 equal to 2. Okay. Next you see, for which variable we get the identity matrix of order 2. Okay. Here you see W1 coefficient is 1 and in the second equation W1 coefficient is 0. So 1 0 and another one is W6. Another one is W6, here we use as a slack variable. So here 1 0 and 1. So here which two variable gives us the identity matrix? W2 and W6 gives us the identity matrix of order 2. So if identity matrix of order 2 or order 3 is given, here 2, so here remaining variable is equal to 0 we consider. Because here 4 variable we consider 0. Then W2, W3, W4, W5 equal to 0. Why not W1 and W6? Because this gives us then basis variable. So basis variable, how we'll get? Remaining 0, then we get, this gives us the basis variable. So we cannot consider W1 equal to 0 and W6 equal to 0. Clear?
Yes, sir.
So earlier problem also you will see, suppose when we use slack variable, suppose three constants are given. Okay, suppose all are less than or equal to. If three constants are given, then what happens? We use S1 plus S2 plus S3. Okay, first constant S1, second constant S2, third constant we use S3. Then what? S1, S2, S3 not equal to 0 we consider. Remaining are 0 consider because S1 and S2, S3 gives us the identity matrix of order 3. So this gives us the basis matrix. This gives us the basis matrix. Then this is called the basic variable. Okay. So here you see W1 and W6 are the basic variable. So I have written here one table B and CB. So B means basic variable, CB is coefficient of the basic variable. And here you see, earlier we have written XB, but here variable all are W. So WB, no problem. In place of X, W. So WB. Then W1, W2, W3, W4, W5, W6. Okay. So next you fill up this one. W1 column, W2 column, W3, W4, W5, W6. So here identity matrix, first column of the identity matrix is W1. So first one is W1. And second column of the identity matrix is W6. So this is W6. And coefficient of W1 is -4 and coefficient of W6 is 0. So I have written this. Okay. Next you ZD dash you calculate same as to WB minus 12 and delta J you calculate same as earlier. Okay. So here one positive delta J in W4 column. So this is our incoming vector. So minimum ratio is WB by W4. So WB by W4 be 3 by 0 is infinite, you will not write. 2 by 1 is 2. So 2 is our minimum ratio. So pivot element is 1 intersecting element. Then W6 will be outgoing and this is replaced by W4. So in the second table here I have written, you see, W1 because 6 is replaced by 4. So similarly, same as earlier operation you apply, then you see we get z d dash equal to minus 10, delta j, all values are less than or equal to 0. Then this gives us the solution of the dual problem. Solution of the dual problem. So what is the value? Here W1 equal to 3, W2 is absent, so 0. In the W3 is also absent in the basic variable, so 0, and W4 equal to 2. Okay, so this is the solution of the dual, but we need the solution of the solution of the dual. So we convert it into the dual. Next, what happened? This is the when we convert from primal to dual, then this is mean. But when we solve it by simplex method, we convert it into maximization. So again, you convert it into the minimization, mean ZD. So mean ZD equal to minus max ZD dash. Same as earlier. So minus minus plus, so 10. Okay. So this is the next we write how to write the solution of the primal, means original problem. So solution of the primal is given by, you see this line is important one. How to read our original problem? How many variable? Two variable, x1 and x2. So x1 and x2, how to consider? So here you see which variable you consider slack or surplus variable. Okay, so here you see we consider x1 equal to either we consider the slack variable or surplus variable. So x1 equal to, we consider here our slack variable is W6 column. So this is our delta 5. So we write minus delta 5. This is the formula. So this will be W5 will be what? Surplus, or W5 is our surplus variable. So this is minus delta 5. So minus minus plus 4, and x2 will be minus delta 6. This is our minus 1. So minus minus plus. So you see the point number 2. Second page, point number 2. You can see how to read delta J. So delta J value with sign changed, means if sign is delta J is minus, so when we write the solution, then this is plus. Okay, means for this reason we have written minus symbol. Okay, so and which delta J we consider? Delta J value will be only consider slack or surplus variable. Other variable we will not consider. So this is the solution of the primal. So our surplus variable is W5. So in W5 column, our delta J is what? Minus 4. So formula is x1 equal to minus delta 5. So delta 5 value is minus 4. So minus into minus plus 4. Similarly, next we consider only the slack or surplus. Other variable will not give the solution. So x2 equal to, next one is our slack. So W6. So W6 equal to minus delta 6. So minus delta 6 value is minus 1. So minus minus plus 1. And makes ZP means primal. So makes ZP equal to mean ZD. You see, this is page number 1, number 1 point. The optimal value of the primal objective function is equal to optimal value of the, in the second page, dual objective function, means max ZP equal to mean ZD. So formula is max ZP equal to mean ZD. Mean ZD is 10. So we write solution will be here max ZP final value is 10. So this line is important. All of you see. This
So
one is Clear or
So
not?
like here in a solution we have like put x1 equals to the surplus variable. So like can we like also put the uh, so like, can you also put the a slack variable instead of surplus in x1? Like is there a rule where we
You
have to
can,
put surplus?
there is no rule. Okay, so only you consider either slack or, because in some problem all variables are what? But sometimes greater than or equal to symbol, all variables are slack, surplus. So you consider all are surplus x1, x2, serially you maintain. Okay, so there is no rule. You in preference will be like this, because W5 is before W6. Consider x1 is first one and W6 is after W5. So we consider this is x2. Because you see, suppose name is, suppose your name Arbaz, then another name is Arif. So if we numbering is like this, A R B, B is first, so your number is suppose 1. Or I is after B, so suppose roll number is 2, like this. So there is no rule whether we consider x1 or x2 like this. Just you remember only slack or surplus variable, we consider x1 and x2. Suppose W5 is surplus here, so first one is x1 you consider, and W6 is after W5, so this x2 we write this. Clear?
Yes, sir. So like so like that means if like W5 was, let's say, slack, then I mean it would like still be the x1, because like I mean there is no problem in like doing that, right?
Mm.
So like I mean the fact that it's like slack or surplus doesn't matter. Just like it's up to us that we have to like put it as a slack or this thing, right?
Yes. You just consider
Okay, sir.
slack or surplus variable is the original solution of x1 or x2. Okay, which one
Yes, sir.
come first? Suppose slack one is W1, W5, then you consider this is x1. Surplus is suppose W6, then you consider this is x2.
Yes, sir. Okay.
So this is the solution of what? This is the solution of how to read the solution to the dual from final simplex table of the primal and vice versa. So actually your question is what? Using dual solve the LPP. Using dual solve the LPP. So first we convert it into the dual. Problem is what? First you convert it into the dual, then you solve, then this gives us the solution of the dual. Okay, but we need the solution of the original problem. So solution of the original problem, how to read these 2 points gives us the solution of the problem. And here number 1 point is maximum ZT equal to mean ZT, and number 2 point is delta J sign is changed for the slack or surplus variable. Means delta J equal to, for this region, minus this is x1 equal to change in sign, means minus. Okay, delta J equal to minus W5 and delta J equal to minus W6, or change in sign this. And this is only we read slack or surplus, not the other variable. So you will try to practice this problem. Okay, next class I shall give. And okay, response